Welcome back to part 3 of our viral Telegram game series. In the last video, we set up our project, installed dependencies, and established our database schema. Today, we are diving deep into the backend logic. We'll create the configuration file that will act as the single source of truth for our game's rules and economy. Then we'll build the most critical API endpoint, the Telegram webhook, that will securely process real payments. Finally, we'll configure our entire local development environment using ngrok to see our app running live inside Telegram for the first time. First things first, let's create a centralized configuration file. This is a crucial best practice that keeps all our important game variables in one place, ensuring consistency between the frontend and backend. Inside the lib folder, I'll create a new subfolder called config, and within that a new file named gameconfig.ts. Let's break down this important file from top to bottom. Max points per game. We start by defining a constant for the maximum points a player can earn in a single game. This is a simple but effective anti-cheat mechanism that we will enforce on the server. Referral config. This object holds the rewards for our referral system. How many points both the referrer and the new user receive. Daily bonuses. An array of objects defining the daily login streak rewards, making it easy to adjust the points for each consecutive day. Levels. This is a large array that defines our entire player progression system. Each level has a name, the total points required to reach it, and a link to its corresponding animal icon. Helper functions. Below the level definitions, we have several utility functions. Calculate user level takes a player's points and tells us their current level. Get level info and get next level info retrieve data for specific levels. And calculate level progress does the math to figure out how close a player is to the next level, which we'll use to render that nice progress bar on the UI. Stars packages and tone packages. Finally, we define the in-game shop. These arrays hold all the data for our point packages, including the price in stars or tone, the number of points awarded, a name, icon, and any promotional badges like best value or 20% bonus. Now for the main event, the Telegram webhook. This is the endpoint that Telegram servers will call to notify us about payments. Security here is paramount. I'll create the file at app/api/telegram webhook/route.ts. This file is dense, so let's walk through it carefully. Validate webhook request. At the very top, we have a security function. It checks for a special header, X Telegram bot API secret token. This ensures that only requests coming from Telegram carrying the secret token we defined in our .env file are processed. Any other request is immediately rejected. Parse compact payload. This utility handles the invoice payload from Telegram. To meet Telegram's 128-byte limit, we designed a compact payload string, Telegram ID, package index, timestamp. This function safely parses that string to get the necessary information. Validate pre-checkout. This is the first step in a Telegram stars payment. When a user confirms a purchase, Telegram sends a pre-checkout query to our webhook. This function validates that the user and the package they are trying to buy are valid before charging them. We respond to Telegram with either an approval or rejection. Post function. This is the main handler for all incoming webhook updates. It first calls our validate webhook request function. It then checks the type of update. If it's a pre-checkout query, it uses our validation logic to respond. If it's a successful payment, the real magic happens. It first checks for duplicate payments by looking up the unique Telegram payment charge ID in our database. This is a critical step for idempotency. Then it wraps the database operations in a db.transaction. This ensures that we both create the purchases record and update the user's points in an atomic all-or-nothing operation, preventing any data inconsistencies. You'll notice a feature flag for refunds. When this is on, the bot will handle a refund command, which is incredibly useful for testing the payment flow without spending real stars. Finally, the handler includes basic logic for bot commands, like start and help, sending back messages with the play game button. Now that we have our webhook endpoint, we need a script to tell Telegram where to send these updates. I'll create a new file at scripts/setup webhook.ts. This is a simple but powerful utility script. It loads our environment variables, constructs the full webhook URL using our next public app URL, and then makes an API call to the Telegram bot API. It first deletes any old webhook to ensure a clean setup, then calls setWebhook, passing our app's URL and, most importantly, our Telegram webhook secret token. Finally, it calls getWebhookInfo to confirm that everything is set up correctly. With our core backend files in place, it's time for the moment of truth, setting up our local development environment to run the app. Since our app is on localhost, Telegram servers can't reach it. We need a tool to expose our local server to the internet. For this, we'll use ngrok. In the terminal, I'll run ngrok http 3000. ngrok generates a unique public HTTPS URL that tunnels directly to our local port 3000. I'll copy this URL. Now we need to update two places. First, in our .env.local file, I'll replace localhost 3000 with the new ngrok URL for the next public app URL variable. This tells our Next.js app what its public address is. Second, I'll go back to botfather in Telegram. I'll use my apps command, select our app, and choose to edit web app URL. I'll paste the ngrok URL here. Now Telegram knows where to send users when they click the play button. With the URLs updated, I'll run our setup script in the terminal. npx tsx scripts/setup-webhook.ts. This tells Telegram to send payment webhooks to our new ngrok address. Finally, let's start our development server with npm run dev. And now for the final test. I'll go to our bot in Telegram and send the start command. The bot replies with our welcome message and the play game button. When I click it, Telegram asks for confirmation to launch the app. After launching and accepting the ngrok warning, you can see the default Next.js page is running live inside Telegram. This confirms that our entire local development setup, including ngrok tunneling and webhook configuration, is working perfectly. And with that, our local development environment is fully operational. We've built a solid foundation with our config file and webhook.